Today we're going to take a look at lesson 2.6 on page 110 of our textbook. Sorry, I had a pop-up on my screen. Be on 110 of your textbook, follow along with me, and we'll kind of go through this. This lesson, quadratic formula, is actually pretty straightforward. There's not a lot to it. It is exactly like it sounds. There's a formula that you just plug the information in, type it into a calculator or do it by hand, and you're done. And it just gives you the information you need. So pretty straightforward concept. So we'll start off with just a quick introductory to it. So here is the quadratic formula. The quadratic formula is used by the vast majority of the world, and it's pretty much the only method that a lot of people use. We've seen a lot of methods to factoring quadratics. I mean, there's different ways to factor. There's different methods to factor. There's guess and check, factor by grouping, slide, divide, bottoms up, box and cross method. There's so many different methods, but the one that I usually point people to, especially if they're struggling, is this, the quadratic formula. There are songs on this. You can go to YouTube, and I would recommend you go to YouTube and search quadratic formula, row, row, row your boat, right? Super popular song. We all heard that as a kid, you know, row, row, row your boat gently down the stream. Basically, it takes this formula and it puts it in that melody, and it helps it stick in your brain. And every year, students, we listen to it in class and over and over and over for multiple days. And after a couple of days, people are singing along on their tests. They're actually writing the formula out by singing it in their head, things like that. So going to YouTube and searching quadratic formula, row, row, row your boat, that'll help you kind of memorize this formula. You know, in this environment, though, you could just have this written down somewhere on your test day, so it's not that big of a deal. But this formula, just plugging in A, B, and C and doing the calculations, as long as you're careful and you do the calculations correctly, will give you the same information that slide, divide, bottoms up, guess and check, factor by grouping, that all of those different methods will give you. And it's basically the x-intercepts. This formula can actually give you other information as well if you know what you're looking for, and we'll kind of go through that and talk about that. But here's an example of what they're talking about. So if they give you any quadratic, it doesn't matter what it is. The cool thing about the quadratic formula is it works with every quadratic that you'll come in contact with. It doesn't matter if it's negative. It doesn't matter if A is something other than 1. It doesn't matter if there's a constant at the end. It doesn't matter what quadratic you're dealing with. You can always take that information, plug it into the quadratic formula, and it will always work. One thing we stressed with like slide, divide, bottoms up and those different factoring methods is that you have to take out that GCF, that greatest common factor that you share. There's not one with this problem, but if you did, you'd have to take that GCF out before you do the math. That's the cool thing about the quadratic formula. You don't have to. It's just the way it sits is what you're going to use. So in this case, we know that A is the coefficient in front of x squared. So A is -3. We know that B is the coefficient in front of X, so B is 7. And we know C is the constant at the end of the problem with no variable, so C is -4. So all you do is take this formula and you go through it and replace every A with whatever your A value is, replace every B with whatever your B value is, and replace your C with whatever C is. Again, the math, the PEMDAS, those kind of things, this negative, you got to be careful, you know, making sure that you're doing the math correctly, but it literally is as easy as kind of like a plug and play. You plug in the information, you calculate it, and you're done. It's pretty nice. So using this example, I've plugged in 7 for B, so I've got -7 on the front, plus or minus, and we'll talk about what that means here in just a little bit, the square root of B squared -4 times A times C, and that entire thing is all divided by 2 times A. Okay? One thing that trips people up is this first part here, this -B. They think that that first thing always has to be negative, and that's not the case. So what I would recommend is you doing kind of what I do when I'm thinking about this problem. If I'm looking through this, I always read this instead of as negative b, I think about this as the opposite of b. So whatever b is, I'm just going to plug in the opposite of b there. You'll notice that b is positive 7, and see what I have? I've got negative 7. So don't think about this as a negative b. I don't want you to think that that first term there always has to be negative. Think about it as the opposite of b. So if b is 7, that first thing is a negative 7. If b is negative 12, that first thing is a positive 12. It's just the opposite. All right. One last tip, be very careful if you're plugging this into the calculator. If you're starting from left to right, you've really got to make sure your parentheses are correct. Your calculator is only as smart as you tell it to be. If you type this in from left to right and you miss a parentheses or whatever, it's going to mess it up and it's going to give you the wrong answer. So what I like to do, I don't like to type this into a calculator. I like to just kind of solve this in multiple steps. And when we start going through these examples, I'll show you what I'm talking about. All right, so for example 1, solve the quadratic equation. So they've got 3x squared minus 4x minus 9. So again, I'm going to use that formula to work through this and solve it. All right, so I'm going to identify my A, B, and C. You might not have to do this, but this is a great first step when you're learning this, is actually write down what A, B, and C are. So in this case, A is positive 3. B is a negative 4. Watch out for that negative. And C is a negative 9, right? So we'll use our formula. And again, that formula is x equals the opposite of B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So here we go. We're just going to plug it in. X equals the opposite of b. In this case, b is negative 4, so I'm plugging in a positive 4. Plus or minus. Again, you might be thinking, what is that? He hasn't talked about that. I will here in just a minute. The square root of b squared. So b is negative 4. So I will square that. Minus 4. It's always minus 4. That's just part of the formula, so that will never change. Times a. A is 3. Times c. C is negative 9. And that entire side of that equation is divided by 2 times a. So a is 3. So here's where I start. Again, if you're a steps person, you should be writing notes right now and saying, I'm starting with what they call the radicand, what's underneath the radical sign. I'm going to simplify that first before I do anything else. So step 1, if you want to write yourself some steps, plug in A, B, and C. That's done. Step 2, calculate the radicand, just what's underneath the radical. I'm not going to touch anything on the outside, just what's underneath the radical. I'm going to slowly start to simplify it. So I still have a 4. I still have a plus or minus. Negative 4 squared, if you have a calculator, you're more than welcome to use that. Negative 4 squared is just the same thing as negative 4 times negative 4, which is 16. 4 times 3 is 12. Technically, that's a negative 4. So negative 4 times 3 is negative 12. Negative 12 times negative 9, that is going to be 108. So plus 108. Again, use a calculator. If you can't do that in your head, that's totally fine. Negative 4 squared, negative 4 times 3 times negative 9 is 108. And then I guess I can go ahead and simplify the bottom. That's pretty easy. 2 times 3 is 6. I'll simplify that radicand a little bit further. So I'll leave that as 4 plus or minus the square root. 16 plus 108 is 124. All right, I'm back. Sorry, I had a delivery at the door. I'm sitting here, 4 plus or minus the square root of 124 divided by 6. If I type in the square root of 124, I don't know, what is that going to be? 10, 11 something, 11 point something, I'm guessing. So it's going to be a decimal. It's not going to be a nice even number. 124 is not a perfect square. So what we want to do here is simplify this radicand. What we can do is we can break up 124 as a perfect square times a number. And I'm going to kind of do this over to the right over here. So I can rewrite the square root of 124 as, let's try 4 should work. 4 times 31. 4 is a perfect square, right? 2 times itself is 4. So we call 4 a perfect square. I can take the square root of 4. I know that the square root of 4 is 2. You can get that by the calculator. You can actually do that in your head. What times itself is 4? 2. So what I can do here is I can simplify this radicand. I can actually take the square root of 4, which comes out as a 2. But since 31 is just a prime number, there's no perfect square times a number to give me 31. It's going to stay kind of locked underneath the radical. I can't do anything with it. So what I can do is I can rewrite root 124 as 2 root 31. So this is just called simplifying a radical. If you don't remember that, if you haven't been shown that before, we're going to do it a bunch of times in this video. Or you can go to YouTube and watch a video on that as well. So I can rewrite this as 4 plus or minus 2 root 31 divided by 6. And I think one thing you'll notice is that all 3 of these terms, the 4, the 2 root 31, the 6, all 3 of those can be divisible by 2, right? You can divide all 3 of them by 2. So that's what we'll do. We're going to go through here and divide everything by 2. So 4 divided by 2 is 2. 2 root 31 divided by 2, basically what's happening is this, 2 root 31 divided by 2. You're simplifying those 2's on the outside, and you're left with just root 31. And then 6 divided by 2 is 3. So now I want to talk about what this plus or minus means, because that kind of throws some people off at the beginning. What's happening here is if I take this quadratic, and I do the math, it's going to give me 2 different x-intercepts, right? Typically, it'll be x equals some number and x equals another number. Not every quadratic has 2 x-intercepts. Some have 1, some have none, right? Here's an example of something with 1 x-intercept when that vertex is right on top of it. So that just has 1 x-intercept. Here's an example with no x-intercepts. Right? That parabola never touches the x-axis. So this parabola would not have any x-intercepts. And we'll talk about that here in a little bit. But here, this plus and minus is kind of leading me in 2 directions. So one direction is I'm going to take that number 2, and I'm going to add root 31 over 3. So that will give me my first x-intercept. And then I can go the other direction, and I can do 2 minus root 31 divided by 3. That'll give me my second x-intercept. So that plus or minus, what it's doing is it's giving you 2 separate x-intercepts. 2 plus root 31 over 3 will give me 1 x-intercept. 2 minus the root 31 over 3 will give me the second x-intercept. Okay? In this case, they're decimals. You could do that. The square root of 31. Let me go ahead and look it up on my phone. So the square root of 31 is 5 points. We'll call it 5.568. Okay. So what we really have here is 2 plus 5.568 over 3, and then we have 2 minus 5.568 over 3. So that will give me my 2 x-intercepts. So this one will be 7.568 divided by 3. This one will be negative 3.568 divided by 3. And then if I do the math, 7.568 divided by 3 is 2.523. So there's one of my x-intercepts. And then the other one, 3.568 divided by 3, that's negative 1.189. All right. Most places are not going to simplify it and write them as two separate numbers like that. If you take a look at your example in your book, they're leaving it with at 2 plus or minus root 31 over 3. So don't feel like you always have to simplify it down to a decimal point. That's fine. This is perfectly acceptable. It's actually, in my book, preferable to leave your answer like that. So since the square root of 31 is just a decimal number, you can't simplify it. Just leave it written like that. All right. And then again, let's try B over here on page 111. So we have x squared minus 9x plus 27 equals 0. So in this case, A is 1, B is negative 9, C is 27. So if we plug these things into the formula, it's x equals the opposite of B. So the opposite of negative 9 is positive 9, plus or minus the square root of B squared minus 4 times A times C. And that entire thing is divided by 2 times A. All right, so again, the first step is to plug in A, B, and C. That second step is to go ahead and simplify that radicand. And then at the end, we can kind of simplify the entire fraction. So I've got 9 plus or minus the square root. Negative 9 squared is 81. Negative 4 times 1 is just negative 4. Negative 4 times 27. That's going to be 108. So minus 108. Let me make sure I did that right in my head. I don't want to keep going if I didn't. Yep, 108. And then that's divided by 2 times 1 is 2. So if you look here, 81 minus 108, that's going to be negative 27. And divide it by 2. So here's the thing that I really want to emphasize here. So I'm going to take my phone and let's see what happens, because I don't know if I've ever done this on my phone. I've only done it on the calculators in the classroom. So we're going to take the square root of negative 27. All right, let's see if this works. So there's negative 27. Hit the square root and look what it says. It says error. You can't do that. It would do the same thing if we were in class, if we had those yellow calculators. You can't do that. It would give you an error message. So this goes back to what we've talked about in the past, the thing that we're skipping called imaginary numbers. Right now in Algebra 2, we're not going to introduce this idea of getting an error. There is a way around this. You can kind of manipulate this equation and basically take out the negative to be able to continue and work this problem out further. But that's historically been a pre-calculus, concept that we've taught people in pre-calc, not in Algebra 2. So I think we're going to stick with that. So if you look on our practice problems inside Canvas, I've annotated or I've skipped the ones that I don't want you to do that are similar to this. So if I made a mistake and there's another one that you come across and you plug everything into the formula, you simplify the radicand and you get a negative number underneath the radical sign, please don't worry about it. I'm glad that you kind of did the math and got through it, but we're not going to worry about tackling imaginary numbers right now during online learning. So you will learn about this next year if you choose to take pre-calc. So, If you want to, you can kind of look at this and maybe, try to figure out what an imaginary number is. It's kind of interesting. It's not that difficult, but again, it's just one more thing on your plate that we don't want to do. So please ignore those. All right. So I think example 2 will be fine. Let's take a look at that. 6x squared minus 7x minus 20 equals 0. What are they trying to do? So what they're doing here is they're choosing 2 different methods. One of the methods that other people use is called factor by grouping. That's just a different method other than guess and check, box and cross, slide, divide, bottoms up. They're just all different methods to come to the same answer. So what they're saying is, which one do you prefer? And I guess we can do them both ways. We can do a slide, divide, bottoms up, because that's my preferred method. It's the quickest, it's the simplest, and that's just the way I like it. And then we can also do a quadratic formula. And we'll see which one, or you can make the decision on which one you like better. All right, so let's do quadratic formula over here on the left. And then we'll do slide, divide, bottoms up on the right. Okay, so quadratic formula, x equals the opposite of b plus or minus the square root of b squared. So I think I'm not going to put -7 squared. I'm just going to go ahead and do it. So b squared, -7 squared is 49 minus 4 times a times c all over 2 times a. Again, there's things that I do to kind of simplify this. I just go ahead and write the opposite of b. Typically, I'll just go ahead and square b. Usually, I'll go ahead and multiply 2 times a because it's pretty straightforward, just to simplify it and just have a little bit less ink on my paper. If you're one of those people that like to write it out like we did with that first example, stick with it. That's cool. So I'm going to keep going here. 7 plus or minus the square root. -4 times 6 is -20. -24. I looked at this and then said it. -24 times -20. That's going to give me 480. 49 plus 480 divided by 12. 49 plus 480, that is 529. And then let's see if 529 is a perfect square. Honestly, I don't know. So I'm typing in my calculator, 529, the square root, and it is, it's 23. That works out super nice. I love those. So 7 plus or minus the square root of 529 is 23. And now these tend to go a lot smoother. People don't have to mess with simplifying that radicand or simplifying the perfect square out of there. It's a lot easier. So let me go ahead and show you. So one of these x-intercepts is going to be 7 plus 23 over 12. And then the other one is going to be 7 minus 23 over 12. Let me emphasize something again. The square root of 529, once you take the square root, that sign goes away. So the square root of 529 is just 23. It's not the square root of 23, okay? That's another common mistake I see people do. So once I take the square root, now it's just 23. The square root sign is gone. So 7 plus 23 is 30. 30 divided by 12 can be simplified down to 15/6. 7 minus 23, so what is that going to be? 23, 16, -16. Let me just again double check. I don't want to keep going and then screw everybody up. Yep, -16. I can simplify that a little bit further. So what is that going to be? That's going to be -8/6, which can simplify down to -4/3. So there are my 2 answers. Not a ton of work. You know, I think plugging everything in is pretty easy. Typically calculating this radicand might be a little bit difficult. Simplifying that radical sometimes, if there's a perfect square in there, that might be a little bit difficult. But again, nothing too crazy. So let's stick with, let's kind of go back to the slide divide bottoms up. Like I said, quadratic formula, you don't have to worry about a GCF. If there's a GCF, you leave it. In this case, there's not, but if there was, I would have to take that GCF out. My equation's equal to 0, which is super important. And now I can identify A, B, and C, same exact values as we use over in the quadratic formula. And then I'll set myself up with my cross. At the top, that's A times C, so 6 times negative 20. At the bottom, that's my B value. All right, I need two numbers that multiply to negative 120, but add to negative 7. So if you're kind of weak with your multiplication facts, this might be a difficult thing for you. You might have to start listing them out, right? 1 times 120. Obviously, there's no way I can add them to get to 7. 2 times 60. 3 times 40. Still way too far apart. Doesn't matter if they're positive or negative. They're still too far apart to add to 7. 4 times 30. Getting closer. I think 5 will work. 5 times 24. Still, like, they're 19 units apart, but, you know, I'm getting closer. We already did 6. Oh, no, we didn't do 6. 6 times 20. 7 is not going to work. 8 should work. 8 times 15. I think that's it. 8 and 15 are 7 units apart. I just need to decide which one is negative. So if they need to add to negative 7, I think 15 is going to have to be negative. Right? 8 times negative 15 is negative 120. And then 8 minus 15 is negative 7. The next step is going back and dividing by A. So I need to go back and divide by 6. And always simplify. That's super important. 8/6 is the same thing as 4/3. Oh, both of those are divisible by 3. So I think that's going to become negative 5/2. Is that right? Divisible by 3? Yeah. And then remember, at this point, you could go back and you could write this out as 2 factors and solve, but it's a lot easier to just take the opposite of these two numbers. So if that's a positive 4/3, it's going to be negative 4/3. If that's a negative 5/2, it's going to be positive 5/2. I just realized that I didn't simplify this down even further. So both of those numbers are divisible by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So there we go. All right. Which method is better? I don't know. To be honest, I think some quadratics, one method might be preferred than the other. So it's kind of up to you. If you're comfortable with flipping back and forth, you can do that. If you're comfortable with only doing quadratic formula, you can do that. It's totally up to you, but both of them will work. All right. That was example 2. Example 3, how can you determine the number and type of roots in the quadratic equation? We talked before about roots. Those are the same thing as x-intercepts. Those are the same thing. Other places call them zeros. All they're talking about are x-intercepts. So when they say roots, they just mean the places where you're crossing the x-axis. You could see this example here has 2 x-intercepts. And if you do the math, these are your 2 x-intercepts here. 7 plus 5 divided by 4 and 7 minus 5 divided by 4. That'll give you your 2 x-intercepts. Here's a different example, like we talked about at the beginning, where there's only 1 x-intercept, just the vertexes right on that x-axis. So again, do the quadratic formula and you get down to what that value is. Negative 12/8 or negative 3/2, right? You always want to simplify that. But then there's this other example that we talked about as well that doesn't even have an x-intercept. It never touches the x-axis. But if you look, take a look. That radicand underneath the radical sign is a negative number. We're not going to get into that now. Just kind of be aware that that exists, but I'm not going to ask you to calculate that and to worry about these imaginary numbers. That's what that I means. It's an imaginary number. So again, just be able to kind of identify that, be comfortable with how those things work, but I'm not expecting you to calculate the imaginary numbers. The cool thing that it's telling you down here is what they're talking about is a piece of the quadratic formula, and it's called the discriminant. So the discriminant is the part that's underneath the radical. So let me take this example here. This part that's underneath the radical, that's what they call the discriminant. It's a very specific thing. They actually have a name for it, right? The discriminant, because it actually gives you some useful information. And that's what this is telling you here. So if you calculate the discriminant, right? Just say you calculate the number and that number is greater than 0. It's 0.1, it's 7, it's 5,000. It doesn't matter what it is, as long as it's greater than 0, then that quadratic will have 2 x-intercepts, okay? Just like with this example up top here. If I calculated the discriminant here, it would tell me that that value of the discriminant would be greater than 0, which tells me I have 2 x-intercepts. The next example is when that discriminant equals 0. So if I calculate the discriminant, I'm not taking the square root. I'm just calculating the part that's underneath the square root. If that equals 0, then that quadratic will have 1 root. Same thing with this middle example here. If I took this quadratic and I calculated the discriminant, so what was it? B squared minus 4 times A times C, that would equal 0, which indicates it has 1 single root. It has 1 x-intercept. And then the last example, if you calculate the discriminant, again, you're not calculating the square root of all that. You're just calculating the part that's underneath the root. If that number is less than 0, so basically if it's negative, then that quadratic will have no roots. It'll have imaginary roots, 2 non-real roots. Basically, it'll be this example right here. That quadratic will never actually touch the x-intercept. It doesn't have any x-intercepts at all. So that's an important thing to kind of keep in mind. Example 4, now we can use that information to kind of interpret the discriminants. So Rachel is about to serve and tosses a tennis ball straight up in the air. The height h of the ball in meters at time t in seconds is given by this function. Will the ball reach a height of 4 meters? So what they're saying there is basically, do you have to calculate the entire quadratic? Do you have to solve for it? No. You can use just that piece called the discriminant to see if this is going to, reach a height of 4 meters. So here's the quadratic that they're giving you. Notice that they replaced h of t with 4, right? Because that's the height that they want to see if that ball reaches it. They want you to rewrite the equation in terms of it equaling 0. So notice they just subtracted 4 from both sides. So they've got negative 5t squared plus 5t minus 2 equals 0. This is important as well. Make sure you identify what a, b, and c are, because those are the pieces of the puzzle you're going to have to plug into that formula. So notice that a is negative 5, b is 5, c is negative 2. Don't stress about, like with other methods like guess and check, factor by grouping, slide, divide, bottoms up. Remember, we had to make sure a was positive. You don't have to do that with the quadratic formula. You just have to plug everything in the way it sits. So what they're saying is to see if you reach this height of 4 meters, you can just calculate the discriminant. So let me go ahead and do this just so I'm doing it live kind of on a piece of paper. So we have this formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. This is the part we're concerned about, the discriminant. So b squared minus 4 times a times c. So let's plug in that information. B is 5. Minus 4, it's always minus 4, times a is negative 5, times c is negative 2. So let's calculate it and see what it gives me. 5 squared is 25. Negative 4 times negative 5 times negative 2, that's lots of negatives, so be careful. Negative 4 times negative 5 is 20. 20 times negative 2 is negative 40. 25 minus 40 is negative 15. Whoa, sorry. 5 squared is 25. Negative 4 times negative 5 times negative 2 is negative 40. 25 minus 40 is negative 15. Remember what they said on that previous page. I'm going to go ahead and move my book back over. When you're talking about the discriminant, if it's greater than 0, you have 2 x-intercepts. If it equals 0, then you have 1 x-intercept. If it's less than 0, it has no x-intercepts. Take a look. Our discriminant is negative. It's less than 0. So if I were to graph this quadratic, let's go back over here. If I were to graph this quadratic that they're giving me here, this thing will never, right, reach 4 meters high because it doesn't have any x-intercepts. So let's see if that's what they're kind of verifying here. Looks like we're getting the same answer. 25 minus 40 is negative 15. Since negative 15 is less than 0, so the equation h equals 4 does not have a solution, right? It will not touch the x-axis. Therefore, the ball does not reach 4 meters, okay? So using the discriminant to calculate things can give us other information than just, you know, what are the basic 2 x-intercepts. We can actually use it to solve kind of other information by using just the information from the discriminant. So be comfortable with that. Make sure you understand, or make sure you can reference this information right here back on page 112. When that discriminant is greater than, equal to, or less than 0, what happens? All right. So we are on page 113. What value or values of b will cause this quadratic to equal 0, to have one real solution? So when you're looking at this, you'll notice that a is 2, c is 18, but there is no b value. That's what you're trying to find, okay? The equation will have a single rational solution when the discriminant is equal to 0. Again, make sure you're comfortable with that information back on page 112, when it's greater than 0, equal to 0, or less than 0. So this example wants us to have specifically one root, one x-intercept. So if that's the case, and we look back on page 112, we know that quadratics will have one x-intercept when they're equal to 0. So take a look at what they're doing here. They're taking that discriminant, they're setting it equal to 0. They're plugging in the 2 known things, 2 and 18, for what is that? B squared minus 4. They're plugging in a and c, but notice that b is still b. That doesn't change because what they're going to do is solve for b. So let's go ahead and work through this. A is 2. C is 18. Negative 4 times 2 is negative 8. Negative 8 times 18 is negative 144. And again, they put that equal to 0 because they want to find out when the discriminant is going to have one x-intercept. So we set it equal to 0. If we want to solve for b, I'm going to go ahead and move that constant over to the other side. And since this is b squared, the only way to undo a square is to take the square root. So just like in the last lesson, the square root and the square kind of undo each other. They undo each other. You're left with just b. And then the square root of 144, if you don't know what it is, it's going to be 12, right? But don't forget, anytime you take the square root of a number, it's always going to include the positive and negative versions. And like we talked about in the last section, it's because 12 times 12 is 144. And negative 12 times negative 12 is also 144. So you want to make sure you include both the positive and negative. So they're saying there are 2 possible equations. You can basically use positive or negative 12, and that's what they did here. The given pieces, 2x squared and 18, and then they added 12x, and then the same thing, but they subtracted 12x. So either one of those would be acceptable. We're on page 114. So at the top of 114 is the concept summary, just kind of emphasizing things that we've talked about already. How long are we into this? I think I'll go ahead and pause this and just kind of break this up into 2 videos because we're already at 43 minutes. So we're going to go ahead and jump into the practice problems. Not a ton of them. I guess we'll go ahead and just go through all the practice problems today, 16 through 34. So be on the lookout for that in part 2.